So we did our project on understanding the bump stock. Team members include Jimmy Johns, Ari Henderson, Anastasia Klosterman, and Heather Riley. The bump stock was invented by retired Air Force veteran Jeremiah Cottle in 2005. Cottle was inspired to create a bump stock when he wanted a rifle with a faster firing speed but could not afford a fully automatic one. The gun attachment Cottle created, known as the bump stock, allows the user to keep their finger on the trigger while the weapon's constant movement causes the gun to continually fire, simulating automatic fire. Bump stocks are legal and fully permitted under federal law, and they cost between $150 to $350. The purpose of our study is to understand how the bump stock works and why it is so popular. Our group proposes to analyze the design of the bump stock. Doing so, it is important to each member for different reasons, but at the end of the day, we all share a curiosity of how well it can duplicate fully automatic fire. The bump stock is a legal device intended to make a semi-automatic rifle function like an automatic one. We will explore the mechanics of bump stock functionality as compared to the mechanics of traditional automatic weapons. We will compare the ergonomics of a gun modified with a bump stock as well as firing rate and accuracy. Our group took a field trip to the Athens Gun Club to gather first-hand information about the bump stock. On this field trip, we wanted to operate a bump stock for better understanding, but one was not available. Even though we were unable to physically analyze the bump stock, we were able to talk with one of the employees who has worked with one before. After learning about the bump stock, we were able to fire an AR-15, and this particular model had full automatic capability. This gave us a chance to fire in semi-automatic mode and fully automatic mode so that we can compare and analyze functionality. The governing equations that we use primarily relate back to the conservation of momentum. This equation takes the velocity of the bullet when it leaves the muzzle and calculates the velocity of the gun when it is fired. We use a position equation to calculate how fast the gun will get into position in order to fire the second round. The initial velocity is based on the conservation of momentum equation, and the acceleration is based on the force applied by holding the gun divided by the mass of the gun. Using the values we calculated for the force as the bullet travels through the barrel, we were able to calculate the acceleration of the bullet by using the equation force equals mass times acceleration. We then used this value in the barrel length 0.4 meters to calculate the amount of time it takes the bullet to travel through the barrel. As you can see in the target picture, the more sporadic bullet holes were caused by a fully automatic rifle, which most closely simulates a rifle with a bump stock attachment. It is almost impossible to be accurate or precise when shooting with a fully automatic or bump stock attachment.
After our trip to Athens Gun Club, we were able to get a better understanding of how the bump stock works, and we would not recommend any improvements for it. The market is just not interested in the accessory, and there is too much difficulty maintaining accurate aim while firing. After learning about the bump stock, it seems the market itself is its biggest hurdle. It's just not popular. Our biggest challenge was not being able to physically test or analyze the bump stock itself, due to regulation, which could cause errors in our data. Another possible cause of error is that different manufacturers use different materials, and there could be variations in the value of weight and other numbers we used in our calculations.